and I work on the Chrome team. And I don't work on the Chrome team by accident. I came to the Chrome team from a past littered with pain and horror and heartache in the IE 6.0 days of the JavaScript thing. JavaScript was a dirty word. HTML was a 4-letter word. And there weren't very many of us left when we started putting together the toolkits of yore that Peter Paul helped document the horror of the browsers that we had to deal with. Having been freshly scarred by building very large applications and the frameworks to support them, the open source JavaScript frameworks to support them, in what was absolutely a hostile environment, I thought I would try and do my homies a solid. And I joined Google to work on a project called Chrome Frame, where we naively thought, well, what we'll do here is we've got this Chrome thing, and it's pretty good. We'll just put it inside of IE so that you don't have to deal with IE anymore. It worked. Many painful hours of, I thought that what I was going to get out of the business of doing was digging around inside the guts of MSDN to trying to find how some undocumented thing works. What I was wrong about was that my job was going to be exactly that, except I would be doing that for COM interfaces in C++, as opposed to doing it for the relatively well-documented JavaScript stuff. I'm kind of an idiot for doing that. But in all of this, I've continued to use JavaScript as sort of my medium, and I've been repaid for that by now having to spend time on the JavaScript Standards Committee. So if you see talks about what's coming in ECMAScript 6, and you're really pissed off about it, you can come find me and beat me later, because I think I might be the only TC39 member here today. So you have my apologies for what we've done in the past and what we're about to do, although I think some of it's quite good. And a couple of years ago, I helped start the project that became what you're now seeing as web components. We had a team at Google. We thought, hey, we didn't have component frameworks. We had built many of them by hand, and you've seen the div soup. There's a wonderful talk happening right now by Rob Dodson, who's giving a talk on Polymer, and there have been many web components talks here today. And so what you're getting the sense of here is that I've spent the last 4 or 5 years of my life trying desperately to fix the things that were wrong with the web in about 2007. This continues. Today, I spend part of my time on the W3C Technical Architecture group, where not only are we trying to fix the specific specifications, but we're also trying to fix parts of the process by which the specifications and the features come to be. If there's ever a chaotic quest, I don't know which one would be more so than this. We are now the people whose job it is to go review the proposed standards that come down the pike. OK. So all of this has led me and a merry band of fellow travelers, many of whom are pictured here, to pen this thing called the Extensible Web Manifesto, which we have viewed as a shot across the bow of browser vendors and standards people about how we think you should be building new stuff in the platform. And that comes from a decade plus of painful experience, right? We've been locked out. The platform is welded shut. JavaScript isn't powerful enough. The APIs you give us are mere echoes of the actual underlying power. Why is that? Why didn't you trust us enough to let us go build the stuff that we actually wanted to build? Is the question. And why can't I plug into a particular thing? So I think of it back in 2009, Joel Weber, who's now no longer at Google, asked me the question, why can't I use these crazy Canvas APIs to go draw the borders of my divs? Right? I've got a 2D drawing API here, and I got a bunch of CSS that hooks these things together, or that lets me configure a bunch of the drawing of borders. Why can't I just use those API calls when I want to draw a border on this thing over here? And the answer is because those two bits of the platform were never designed together. They were never reflected in each other, and no one really said, it's my job to go join them up. So this is what I've made my job. I've made my job to go join them up. Because I think the web platform and the web is one of the most important cultural artifacts of certainly our lives. There's very little else that has enabled people who wouldn't call themselves engineers, people who wouldn't call themselves developers, to go build a thing that's awesome for somebody else. VB is probably the closest thing in front of it. Visual Fox Pro is pretty good for its time. Logo, if you ever used it, right? I mean, we've had systems that are democratic, We've had systems in the past that enfranchise people who don't think of themselves as programmers to go build stuff. Excel macros are my favorite. You wouldn't believe the size of companies that are run almost entirely on Excel macros and VBA. And it's not an accident, because it turned people who were really freaking good at their job, at the thing that they're experts in, perhaps world experts in, and it allowed them to go leverage the power of computers to do something amazing for themselves too, right? We sit here awash in CPU and GPU power, and we bitch and moan about how our languages aren't fast enough and such is hard. But for someone who isn't a programmer, these tools that allow you to take a thing, copy and paste, and get a thing on the screen, and then hand it to somebody else, these are the most important things. And this is the democratizing effect that the web has had. And by the way, because it's declarative, it's also had the effect of allowing us to understand what those people meant to say in most cases. HTML's markup-based way of doing business allows us to walk around the web with a giant web crawler and then make sense of the relationships between the things later, right? No system since, not the ones in your pockets, not the ones on your desktops, not Windows, not Mac OS, not Linux, not iOS, not Android. None of these systems have enabled the general understanding of content that the web has enabled, almost as a side effect. So these are really important properties, and I think we should be afraid of losing them. I think these are the most important things that we can give to our future selves and the people who come after us, because they won't understand necessarily what we meant. This is the Rosetta Stone. The United Kingdom borrowed the Rosetta Stone in the late 1700s, and it's been sitting in the British Museum since 1802. This may be the only clean picture of the Rosetta Stone that you can find, liberally licensed, because it looks almost like this every single time you go there. I used to live a couple of blocks away from the British Museum in London. And what you get every day, every hour of every day on the West Wing as you walk out of the main hall is this scene where there are dozens of people all taking the worst photograph of the Rosetta Stone. It's like some sort of a competition, who, by the way, are aided and abetted all the time by the fact that camera manufacturers and phone manufacturers hate their customers' guts. How else do you explain the existence of flashes? Right? There was a time when having a flash on a camera involved gunpowder and fire. It was frickin' cool. That was a very long time ago. Flash has been not cool since at least the early 1900s, right? So you'll see this scene where people are there, and then inevitably one of those people will turn around and hand it to a friend and do this in front of the Rosetta Stone, which is then going to be washed out entirely by the flash. So they've got a picture of them in front of a reflective glass doing what they could have done at home. This is the power of understanding. Everyone wants to be near it. Understanding and being able to communicate with your fellow humans is the most important thing, and that's why I work on the web. That's why I spend all of my time fighting what seem to be ridiculous odds to try to get this platform to be good, because I don't believe that open wins. I don't think the evidence is on the side of open winning. I think the evidence is on the side of open winning when it's good enough. So what are we missing is the question that I like to ask. What is it to be good enough? Like, what is the competition? Where are we deficient? How can we be better? And how can we get equivalence when we can't be better? How can we be good enough so that developers and users want to use the stuff that we make? Because as someone who works on the platform, it's my job to hopefully help ensure that the platform that we're giving you is good enough so that when you build a thing, it's good enough for your users, right? There's a whole hierarchy here, and it's long and it's boring. But I'm going to skip straight to service workers by postulating that for these things in your pockets, the default state of the world is that offline happens. Offline is just how it goes. So I was living in London in 2011, 2012, and just before the 2012 Olympics, the mayor of London said, you know what we're going to do? We're going to put Wi-Fi in all of the tube. This is a brilliant idea, actually, because normally you're in the tube, and I honestly think that there must be some sort of collusion between the newspaper industry in the UK and TfL, because otherwise they would have wired it a long time ago like they do in Japan. Because the only way that you get a newspaper in the UK is you just sort of pick one off a seat. Anyway, because they're everywhere. Because the Wi-Fi doesn't work, or your reception doesn't work, as soon as you're underground, on the underground. And so what they did is they wired up all of the stations, not the cars, mind, the stations with free Wi-Fi. OK, so just if you haven't been there, if you haven't experienced this firsthand, just imagine it's like going into a tunnel once every 2 minutes, right? So you can happily associate, assuming that you're not sort of like in some sort of bad state with the Wi-Fi, whatever. You can happily associate, and you think you've got a connection, and it's sort of starting to do the TCP handshake, and like you've got some content coming in. You can almost refresh your Twitter feed, and then you're taking off, right? This is the basic experience of life in the mobile world, because we actually don't have connections everywhere. So, and how does the mobile web deal with this? Well, the mobile web deals with this roughly like this. It's a very sad panda moment, or in this case, sad T-Rex, because he can't reach the keys. We've had attempts at technical solutions. This chart is courtesy of my co-designer of AppCache and good friend, Jake Archibald, who is much funnier than I am. So it's a shame that he's not giving this talk. He wouldn't give this talk. He'd give a funnier one. Anyway, you get what I'm saying. But this is the decision tree that AppCache causes you to have to reason about in a very, very terse format. And I won't show you the terse format, because the difference between this decision tree and that terse format will actually cause your brain to explode. So just instead, trust me, if you go and look at AppCache examples, you'll see small lines, like things that look like prefer online, which is to say, please go try to check to see if something is online before you go and try to fetch it from the cache. You can't do that on a per resource basis. You get to choose whether or not you want to do that for everything all the time. Now remember that the TCP window teardown window is about 2 minutes. Right? You can have a TCP connection stay up for about 2 minutes in a normally configured client before it gives up and goes away. You could be sitting there for 2 minutes as the tube merrily goes from stop to stop to stop to stop, waiting with that little spinner going for it to tell you, oh, no, I actually can't get you anything. Right? This pretty much blows. We have some solutions, other technical solutions, not AppCache. Cordova is probably the best known of them, and it's fantastic technology. Cordova is great. But Cordova pushes you into the game of making the same choice that you would if you were going to try to build a Windows 8 application, or if you're going to try to build a Palm OS application, dear departed Palm, pour one out for our homies. Or if you're going to try to build an Adobe Air application, or if you're going to try to build a Chrome application, or if you're going to try to build, I'm missing a couple, BlackBerry applications, web applications. There's at least a couple more attempts that look almost exactly identical. And what the people the smart, well-intentioned, incredibly thoughtful business people and engineers sat down and said was, you know what web developers want? They don't want to be pushing stuff to websites anymore. What they really want is to put all their stuff in a zip file, send it to our app store, and then have users find it there and then install it. But then what they want is to write the contents of that thing that's not on the web, that doesn't have URLs, that isn't linkable, and totally changes their development workflow. They want to write that thing in HTML, JavaScript, and CSS. Yes. We have attempted this feat, I think, at least 6 times collectively as an industry. At least 7, Firefox OS. Sorry. My apologies. Everyone, it's best not to forget about Dre. So my thought here is that if it hurts, maybe you should stop doing that. On the thesis that if you can't link to it, it's not actually part of the web. They may be quote-unquote web technologies because they're technologies that happen to have found a happy home in the web. But trust me, as someone who hates JavaScript enough to go sit in standards committees meetings about it to try to improve it, this is not for people who don't hate what you're working on. If someone who doesn't think it can be improved enough to want to do it, if I thought JavaScript was perfect, right, I might see their point, but it's not, right? There's a lot to do. CSS is abjectly terrible most of the time, in all places and in all ways. Wait, Is someone going to fight me? OK, good. We're cool. All right, yeah. Seriously, no, I'm right. HTML is just a really nice container for this stuff, and it has a lot of interesting properties, and it's linkable, and you've got this default navigation behavior, which these other application platforms also break. So you can see how this is we have a lot of momentum with web stuff, because web stuff is truly amazing. It's linkable, it's indexable, it's crawlable, it's safe, it's secure, but it doesn't do all this other stuff. It's not on the home screen. It doesn't work offline. And when it doesn't work offline, you blame the platform. You don't blame the application. Right? A well-written native application will show you the stuff that it's got cached when you launch it, and then it'll say, I'm sorry, I can't get you anything new. Right? That's kind of the MO of a well-written app. A well-written web app, you type in the URL, and if you're offline, you get nothing. Right? You get the little dinosaur. So that sucks. But the price, so today we're making a trade-off. I can choose to have a thing that works offline. I mean, really, app cache isn't actually an answer. Or I can choose to have it not be on the web. Those are kind of it's a binary choice, and it sucks, because I have to throw out URLs, I have to throw out indexability. I have to build things a totally separate way if I want to have a product that works offline versus something that doesn't. That's pretty bad. And if you think about the way applications are constructed, like applications, not websites. I mean, we'll talk about websites in a second. But if you think about the way applications are constructed, you could think about them as being a shell of stuff, navigation around the outside, and then actual content that sort of sits in the middle. This is really common. My blog works this way. I bet your blog works this way. I bet if you look at Wikipedia and sort of squint a little bit, you see the navigation stuff around the outside, and then you see the content in the middle. And the URL tends to address the content in the middle. Right? The URL tends to be about the content in the middle, not about the navigation stuff around the outside. This is actually almost true for most of the kinds of applications that you work with on a daily basis, specifically the ones that are popular, because they tend to have good URLs. So an application is a shell, the thing that goes around the outside, and some content. Now, the way we build HTML today is we smush all those things together, and we send them down the wire as one big bundle, and we say, aha, now you have a web page. Well, your web page is actually multiple things. It's the navigation stuff around the outside that you carefully use a templating system to recreate every single time someone loads the document. Or if you are an advanced developer, quote unquote, and you use a very large framework, you can avoid reloading that bit every time you go to a new state. And you can just reload the content or change the content inside the thing in response to someone clicking the link or navigating to a different part of the application. So we have two things. We have two separate things. And one of them is the stuff you need to construct the shell. And the other thing is the stuff that the shell mediates for, right? The content that the shell has loaded. And so one of the things that app cache has failed us at, and the regular web platform is difficult to reason about in terms of, is the idea of having a shell and having content. We have pages. And the web knows how to do pages, which are things with URLs that the server sends you as a hermetic whole. And then we have single-page applications where the points don't matter and the rules are made up. Right? It's stuff that is all JavaScript mediated. But the URLs are something you have to work back to, something you have to use a particularly enlightened framework, something like Ember, to go recreate for you on the basis of moving through a local view. So app cache doesn't support that, really, because it only lets you cache. Well, you could try to cache everything, but that'd be pain and heartache. Or you could put all of your content inside of a database and your shell inside of the app cache, and then boot the shell up, and then try to look at the URL and try to parse it all out, and then pull some stuff out of the database. And if that thing is an image, well, now you have to figure out how to load an image when you're not actually using HTTP:// or whatever to load your images. That sucks. Right? Now you have to contemplate building your thing a totally different way. I think, I'm just going to be, I'm going to generalize here, but what I want, and I think you probably want, is to not change the fact that the way you made a web thing is you put it on the server someplace and hit publish, or you FTP'd it up, if you're old school. Is that you put a thing on a web server, and now it's a web thing that someone can go to. And you can change it quickly, and you can change it all the time. That's great. And we tend to put proxies in front of those things. In many cases, at big companies, we use proxies to both modify the content or to improve it in some way or add little bits of stuff that goes along for the ride. So service workers are like an in-browser proxy. They are like something that sits behind the document, but in front of the network that you can program. So one of our litmus tests for the design of service workers has been to try to explain how app cache works. This all comes back to the how the heck does that thing do what it does, right? So we built this thing called app cache, and it does some of the stuff that we want. Like it lets us cache shells or content or both if you're super crazy. But it doesn't give us more than one cache, although there are multiple caches, obviously, because if I go to multiple sites, the browser will create more than one of these. But why can't I have more than one for my thing? It has a bunch of really interesting behavior about when it fetches stuff, how it caches stuff, when those caches are evicted, but none of that's programmable. Why is that true? How does it work? So we're creating an answer with service workers that lets you explain how it works. We're not going to like make it do the same stuff. It's not going to be insane. But we're going to give you the power to do all the same exact insane things if you want to. Hopefully you won't, but you know, horses for courses. So it's installed the first time you visit a document. It's like a regular web worker, except that instead of saying new worker and getting a handle to this thing, you go and install it, and then the browser wakes it up when it decides it needs to. And we'll talk about that in a second. Once it is successfully installed, that is to say, once it does potentially a multi-step installation dance, it'll start to be consulted by the browser when you navigate to things that it controls, which is simpler than it sounds. And it gives you control over requests and responses and caches. And you can have more than one cache. You can have multiple caches. You can name them. You can control them. You can delete them. You can create them. They're mutable. And you can, like with a regular worker, post message between the service worker and documents that it knows about. So it's sort of like a shared worker, except you'll see it begins and ends life much more frequently. And then it has some smarts to help you mediate the problem of going from version 1 to version 2 and from version 2 to version 3. So this is one of the most difficult and nasty parts of the specification. We'll spend the least time on it because upgrades are a pain. But just rest assured that the default policy is that you will have an opportunity to do something sane. And if you do something different, well, it's all on you. And I think the most important part about service workers is that they progressively enhance things. We're not trying with service workers to change the way that you build web apps. I think you're going to change the way you build web apps in the near future anyway. Right? The revolution is sort of on us now about the frameworks that are doing client-side MVC and data binding and really rich data modeling and synchronization. But service workers are not going to impose that on you. If you want to use them in that way, that's great. But you can use them to progressively enhance an existing website too. So here's how you do it. This is hot sample code. So the main bits are that you have to go to a web page to install a service worker. This is not magic. It doesn't come in a header, right? So the first document that your application loads is going to be something that the service worker is not in control of. Right? Your proxy is not yet installed, so you have to send the user something meaningful anyway. This is good. I actually think this is great, because what this means is that you will have a reason to resist the temptation to go make your thing one of these totally single-page JavaScript hairballs that's never accessible, that doesn't work on anything that doesn't run JavaScript, that you can't sort of throw away your server. You'll continue to have to think about what it means to be searched and crawled. This is, I think, a good thing. But what you see in the register call is that you pass the location of a script, and this script has to be on the same origin. The script can't be on a CDN. There's a security reason for this, and I apologize for it. And you can also optionally pass a bag of parameters, but the important one here is the scope. This scope can be a longest prefix match for anything on your origin. In this case, the default is star, but it could be like /app/star. But basically what that means is whenever I navigate to a document, click a URL or type a URL into the location bar, if the location of that navigation, a top-level navigation, matches this pattern, this service worker will receive an event asking it, what should I do about this navigation, right? OK, so let's say that that all happens and control.js is installed. At some point in the future, when that dance all finishes, we can use the promise that's returned from when ready to talk to our service worker, right? It'll be handed back to us, and we can just post messages to it. Obviously, this is the least interesting thing you can do with the service worker. If you just wanted to have a conversation with yourself, you could post a message to a worker that you create manually, right? Having conversations with yourselves might be a great way to sort of, work through the day's pain and heartache over a drink, but I don't recommend that either. So this is what the service worker itself looks like. It is a script. It's actually a script that looks a lot like workers do. Who's written any web worker code? Right, hearty souls. How many of you hate the fact that until late last year you couldn't use console logging in them? OK, all the same hands. Yeah. Now I know you're not lying. So basically the way this works is that there are a series of events that you can listen to. And if you don't listen to them, they probably won't be sent to you. So you should make sure that in the top level you put event handlers on it. If you like that, you should have put an event handler on it, is the takeaway. So in this case, we're going to listen for the install event and the fetch event. And these are two important events in the lifecycle. The install event will be sent in as a result of that application that service worker installation process, right? When I call register, the browser is going to go fetch control.js, and it's going to, if it parses and starts correctly, it's going to send the install event. Now, you can see that while we had to load control.js from the same origin, we can import scripts from third parties. So if Twitter or Facebook or somebody else with a popular social product, which is to say not Google, wants to provide you with one of these buttons that you can use to NASCAR up your website, and they've got a service worker equivalent to help cache their stuff, you can import it using the importScripts method here. OK, so assuming that that all went well and those scripts were downloaded and cached along with the contents of control.js, and it all parsed, and your execution context is started, you get the install event, and then you can say, wait a minute, I'm not done. Hold on now. I'm not done installing. So normally what happens is that because this is an entirely event-driven context, that is to say, service workers begin and end life at the whim of the browser. That they are started when an event is needed, and they're killed almost exactly afterwards. It would suck to want to go download a bunch of stuff, not have any synchronous APIs to go do it with, because we're not giving you any synchronous APIs, because this is a latency-sensitive context. Sorry, guys. And then not be able to say, wait, no, I'm not done yet. I need to go get all these images of cats. So let's say we wanted to cache some cat images. We can say, don't consider the installation process finished until the promise that I hand you resolves successfully. So that's what the wait until method is. And you'll see wait until all over the service worker API. But the basic idea here is that you can use wait until plus a promise to extend the life of one of these event handlers beyond the direct execution flow of the top to bottom running of that function call. Does that make sense? OK. I know promises are not, there's no promise talk here, I think. But promises are a new thing in ECMAScript 6. We drove them in ECMAScript 6 because we needed them for service workers. But everybody else wants them anyway. So I, for one, welcome the new promise overlords. They've promised me some stuff asynchronously. We'll see if they're good for it. OK, so now I've installed my stuff, and nothing happens. In fact, what happens at the end of this install event is if, let's say, I go get all my cat images, this execution context probably gets killed. If I store it in a state in a global variable, it's gone. But next time, I navigate to example.com/maybe fuzzy kittens. Because remember, I match for anything that will glob to star, which is to say fuzzy kittens will match. I go to fuzzy kittens. I will get a fetch event. The service worker will be restarted, and an event will be sent to it. And now I can respond to the event. In this case, if it's a top-level navigation, I can distinguish that using the event object's is top-level thing, and I can see what I'm getting. Great. But let's say it's not top-level. Let's say we deal with a top-level thing somewhere in code you can't see here, because I can have multiple event handlers. But I get a sub-resource request for some JSON data. Great. That's awesome. Maybe I have this data cached. Maybe I just want to give it back to you manually. We can actually create a response object that conses up the contents of our cats thing. Right? We could pull it out of this cache object that we created before, and I'll show you how to do that in a second. But one of the powerful things about service workers is that you can use them for things like client-side templating. you can actually go and create something like this that happens to just cons up a response out of thin air, just creates it out of thin air. This is a programmable context that you can use to feed data back to documents. Like, we're not kidding around. You can create images. You can do whatever, right? The sky's the limit. Just do it quickly, because there might be a request in line behind you, is the idea. So a couple of things to remember about this little code snippet we've just seen. This only works over SSL. So we've been catching a lot of flack on the Twitters about this, and I think a lot of it's justified. But the other side, the thing that you haven't considered potentially, is that in the design space for this system, if we don't insist on SSL, any Tom, Dick, and Harry who can get between you and the place you want to go can potentially do bad things. And that means that any airport Wi-Fi, any hotel Wi-Fi, any intermittently connected thing or any terrible router can go totally own you. And because service workers are persistent and they live a long time, potentially on your system, that's really bad news. They amplify the potential downsides of any of these attacks. And that's particularly nasty. So we're going to do everything we can to keep that from happening. And the alternative would be a bunch of really nasty mitigations that we'd have to put into the spec, like treating anything that's not a 200 response for one of these scripts as something that evicts it, which would suck, because it would mean that you would have your application until you went to the hotel Wi-Fi and then left the hotel Wi-Fi. But because it didn't give you a 200 response for that thing, we uninstalled your application. Right? That seems bad. But that's the sort of crazy stuff we would have to do. So SSL is a requirement. It's also the case that it's 2014, and Edward Snowden told us and showed us that the people that maybe you don't trust want to know everything about you, and non-encrypting connections is the easiest and fastest way to do it. So welcome to the SSL web. We think that this is a good thing to do for humanity. That installation step is totally asynchronous. Right? The browser can start that installation step when it wants, and you can finish it basically whenever you want. There's going to be some sort of an execution lifetime cap. Like, you can't totally abuse it. But for installation, it'll probably be on the order of minutes. For handling fetches, it'll probably be on the order of seconds. So if you don't install successfully within some period of time, your service worker will be killed and your installation won't succeed. But it is asynchronous. And remember that that installation is based on the scope, the tuple of the origin that you came from and some pattern. And that pattern can be whatever you want, but it's implicitly tied to the origin that you install the service worker at. Requests for sub-resources like that JSON data only come through the service worker if the top-level document also matches that service worker. So let's say I install a service worker for acme.com and for example.com. I go to acme.com and I install one. I go to example.com and I install one. A resource requested from acme.com to example.com will run through the acme.com service worker, but not the example.com service worker. Right? Everything is relative to where something was installed from, and you will only ever be consulted about sub-resources if the document itself was something that matched the service worker. Does that make sense? So you can see what requests you're making to third parties, but the only person you can lie to is yourself. OK, cool. They're very much worker-like from the perspective of the document. You can post messages to them. You can create message ports, that sort of thing. But their lifetime, they get killed frequently. So don't count on them to know a lot of stuff unless they put it in a database someplace. And you shouldn't keep state and globals. And if you don't use import scripts at the top level, if you want to put something in an import scripts in a conditional someplace, this is probably bad news. Because it means that it might not get fetched the first time it runs, which means it might not get cached, which means it might not be available when you're offline. So try to put those things in the top level. We're going to, in a version of, in an iteration soon, add an implicit cache object that you can program that will include all the stuff that import scripts pulled in. But that's not in any implementation yet. And there's no synchronous APIs inside of service workers. So the reason for this is that because fetches might be coming hot and heavy in the same way that they might in, say, a Node.js environment, it's on you to respond and get out of the way as quickly as possible. You can do work asynchronously. You can do lots of work asynchronously. And there's lots of nice asynchronous APIs to help you out. IndexedDB is asynchronous. Promises are asynchronous. So you can start work handle it asynchronously, but just don't block the head of the queue. Just don't sit there and be like, if I don't have the answer now, I don't know what to do. I should wait while one. Don't do that. It's the fast way to have your service worker killed by the host. OK, so what are some fun and useless things I can do with service workers? So remember that we might have created a cache for that fallback image, or for some image, right? Like maybe it's a cat, and we don't have the cats, and we really want our cute little dinosaur if we don't have the cat. So let's say we get a fetch, and it's for an image. The request is a request object, but it's got a URL, and we can test it. Let's say we want to see if we can get it from the network first, and if we can't get it from the network, we want to get it from that local cache. We want to hand you back the fallback one. Doing this inside of service workers, you can do this on a per request basis. You can do this on a per resource basis. You can do something similar here where it's all type dependent. And there's a new fetch API, which is the XHR you always wanted. You're welcome. And so you hand it a request object. It hands you back a promise. I know. I know. And if it doesn't successfully respond, if you don't get something back from the fetch, you can use the catch method of it to go pull something out of the cache. So this caches object is the global set of all caches. And if you hand it a request or a URL, it'll try to match the first one it finds. There are individual caches, like we saw with the cats one earlier. You can create your own, and you can pull them out of the caches object asynchronously and deal with them individually. But this is just sort of a convenience method to let you go fetch something, because you probably know you want it. So in this case, we can hand back a fallback if we try the network first. This is pretty great. We can also do transparent caching, right? This is kind of crazy pants. Let's say someone makes a request for an image. We try to get it from the cache, right? And if we don't have it, Jake Archibald wrote this code, and it's great. I love it. I love how terse it is. Let's see if we can have it from the cache. If we get it from the cache, great, hand it back. If we don't get it from the cache, we'll go get it from this temporary cache that we created up here in onInstall. And if what we'll do is we'll get the cache object, and then once we have the cache object, we'll go tell the cache object to cache this thing, so that the next time you request it, we'll make sure that the next time you fetch it, you just pull it out of the cache. But we'll actually return the thing from the fetch. We'll actually go and get the resource off the network. So this is like transparent proxy caching in, what is that, 15 lines or less, including the setup. This is the sort of power that service workers have and will allow you to exploit. So let's talk about upgrades for just a second. So upgrades suck. So it's often the case that upgrades and deployment in general is something that you're doing across multiple data centers or across multiple geographies with clients who visit you infrequently and may have old versions of content. The way the service worker update thing works is that when you navigate to a controlled document, we're going to check for a new service worker if we haven't checked for one in the last 24 hours. You can set the cache as far future as you like, but we won't let you shoot yourself in the foot that way. One of the canonical things that people get wrong with app cache is that they set a far future expire header and then forget that what that means is that any client who's got that application cache will never see an update to the entire website, including the application, ever. That sucks. So that's not how service workers work. There's a 24-hour window. You can set it to be shorter, and you'll maybe check on every update or check on every time you navigate to a document in the application. But max 24 hours. But maybe someone's been offline for a long time. Maybe they got stuck in the maze of the tube for weeks, and they came back up for air, and they're on a really old version. OK, well, what do you do? Service worker has your back. We check for an update to the service worker script, and if it's different by a byte, we'll go fetch the new one. And then if we get the new one and it parses correctly, we'll send it this install event again. And that install event is the only time where you'll have really two service workers potentially running at the same time. So you should be careful not to do something crazy by like blowing away databases inside the install event. There's a separate event that lets you do things like cleaning up your old stuff. Because these are programmatic, right? We're not going to respect HTTP expiration on the resources that you put in these caches. This is up to you. This is a programmatic cache. You get to choose when and what to do with the contents of it. It's up to you to remove them so you don't blow away your quota. So There's a separate activate event, which we haven't seen before. And the activate event is the moment where you're about to become the guy in control of some new bit of content or some new fetch. But we know that we're running a new version. Ooh. We know that we're running a new version and not an old version. And there may have been an old version instead. And so this is your chance to go do stuff like schema migrations for databases and removing old caches. And if there's some extra work you need to do, now's your chance. Be quick about it, though. It's as latency sensitive as the fetch event. So try to get out of the way quickly if you can. And then by the time you get a fetch event in this service worker, you can know that you're dealing with the latest version. There's some difficulty around which windows see what. And so the way the service worker default policy works here in terms of upgrades is we sort of do what Chrome does, where once your application is totally shut down, the next time you launch it, like when there's no tabs that are running inside of the space that you've used as a control, like in that pattern, example.com/star, if there's no tabs that are controlled by that and you shut them all down, the next time you'll get the new version. If you have a tab open for a long time and you've got another service worker in waiting, it can get this install event and upgrade itself multiple times. In the interim, you can continue to get new versions and process them and just be waiting for all the tabs to close until they all close, and the next time you're started, you get the latest and greatest version. So the system is there to mediate this process for you and to help you out by keeping it sane. If you really want control, inside the install event, there's a method called it's like I didn't design it. There's a method that allows you to take control immediately of all the active documents that potentially run and kill the old service worker. There's also a method called reload all, which lets you refresh everything in an atomic way. And those are both ways to help you do this dance effectively. But it's a lot of detail. Generally speaking, the default policy should work for everyone. And if it doesn't, please send us an issue in the GitHub area and the GitHub issues list. OK. So there's a bunch of opportunities here once you've got a programmatic cache that you can control that gets sent events every time it wants something. That's pretty great, right? Obviously, not on first request, but soon thereafter. We can do client-side templating and routing. Right? You can move a lot of your application logic to the client if you want to. You can do data model synchronization engines. So let's say you don't want to fight over which tab owns the data. Or your databases. Well, the service worker might be able to own them. And you can do background synchronization from there. Local disk is fast, but we saw a case earlier where we tried from the network, and if we didn't get it, we went to the local disk. Service workers, because they're promise-based, even allow you to race. You can try to get something from the local cache if you've got it, or try to get it from the network and come back with whichever one is faster. Turns out this actually happens. Not this device, but most low-end smartphone devices are running these days on something called MLC, multi-layer flash. And MLC is terrible. Like you think about the SSD that's inside your laptop, and it's super fast. MLC is not that. It is flash in theory, but it is not that. The latencies are bad and getting worse. So sometimes it might be useful to try to go to race on the network. You can even start to prime connections in that first fetch. You can be like, I know I need to go talk to those CDNs in a minute. I'll just send a warm-up ping out there to go get the TCP and DNS and all that stuff warmed up so that the next time I come along, I can cut that connection short. Because we're not trying to do all this from inside the document, you'll just get events as they come in from the preload scanner. So we're not changing the policy about the preload scanner. So this is all friendly to the preload scanner. You can continue to be part of all the optimizations that the browser is aggressively attempting to implement on the renderer side. And you could even do your own request reordering. I don't recommend this. We're talking with folks at the network layer to see if we can give you much more explicit control in the fetch API over the priority that goes into the buckets for outbound requests. But if you're really backed up against a wall and you need to do request reordering, service workers even allow you to do that. And there's a lot of future stuff coming. We need to make service workers stream friendly. There's a streams API that's coming at the W3C. And we're actively engaged with that and hope that it will allow us to do things like sanely and intelligently cache multi-gigabyte movies instead of trying to reify them all into the service worker memory and then fail. And then there's a bunch of interesting stuff that's potentially coming down the pike where we're talking with people about extension APIs, new events that would get plumbed into the service worker, APIs that will live in the document but which might send events to the service worker. Background synchronization is kind of an obvious one. You can imagine an application wanting to be woken up, to cache the latest data at some point. You can also imagine push messaging. There's an active debate at the W3C right now about the spec for push messaging, and we're heavily engaged there. But the service worker is the natural place for a push event to be dispatched to, because your application may not be alive, right? The service worker might be the thing that can handle the push, save it to a database so that the next time you're there, do something about it, or maybe send a notification as a result of that. There's also work at the W3C to add notifications to the web platform. We have challenges around quota. The quota API isn't really set up for this, and we're talking actively to go try to improve that story. And I said now-ish. What I really mean is soon. And by soon, I mean this year. So right now, we've got a first public working draft of the spec at the W3C. After something like a year and change of hammering it out in the open on GitHub collaboratively with folks from Mozilla and Samsung and even some folks from Intel. And a bunch of interested community members, right? This all happened because a lot of people got together and said, App Cache isn't doing it for us. And the Financial Times guys specifically got together a bunch of people in a room and said, hey, what needs to be better? And so now, a year and change later, we've got multiple implementations that are currently underway. Inside of Chrome, we have the installation steps and the upgrade steps almost finished. Script persistence isn't quite there, but it's hopefully this week. Firefox is slightly ahead. They've got installation and some of the request and response stuff. Chrome will send you the fetch event, but you won't get any information about it. You can't know what's being fetched, and you can't send anything back. That's coming very shortly. And I think in everyone's implementation, the cache API is going to be polyfilled on top of IndexedDB with blob support in the near future. All right. I know that I'm running a little bit tight for questions. I wanted to leave 10 minutes, but we don't quite have that much. Thank you so much for your attention, and I'm excited that we're going to finally make apps that work well offline. Thanks. Questions? Anyone? Yeah.
Any news on how well or whether IE is going to start implementing that?
So the question is, any news on whether or not IE is going to support that? Adrian Bateman was at the Microsoft booth downstairs. I recommend you ask him. Aside from that, one of the key drivers for getting a spec published at the W3C is that it allows us to collaborate with folks whose patent policies preclude them from, say, just throwing ideas over the wall on a GitHub repo. So we've started that engagement a couple of months ago. We've been talking about the W3C and moving the spec to the W3C for a while, but that finally just happened. And we're starting to work through issues publicly. I can't commit to their time frame or anything like that, but yeah. How about WebKit? So again, Apple is the sort of kingdom where commitments about future public plans are not common or encouraged. So we haven't seen implementation work from them in WebKit trunk, but because so much of this happens on the browser side and not the renderer side, it's unclear what that even would mean. I mean, we might see it in public, but we might not. We're excited to be working with Firefox, though. We've been collaboratively designing with them for a while. And I think this is such a fundamental new capability that once web developers get to be able to use it, I hope the demand is high enough that we won't, it won't be a question for long. Yeah. Yeah, what's the opportunity for polyfills? None. But that's the price you pay for adding a fundamental new capability to the web platform. So I think Tom Ashworth at Twitter did a Node.js-based server polyfill that you can try out now. It's pretty great. And it lets you play around with the API, but of course, your thing won't work offline because it has to use a server. So the issue is the first request. So local storage will give you stuff once your document is booted, but how do you get that document to boot is the question, right? That first document, how do you service that request? So service workers are part of that conversation as well. You receive fetch events for those things. For all the other stuff, you might be able to polyfill it, but I'm not sure how useful that is. I mean, you could maybe cobble something together with an app cache, and I don't know.
Conversion script from app cache to service worker.
Yeah, Christian's talking about a conversion script from app cache to service workers. That would be totally doable. That would actually be interesting. Yeah. Yeah. I said there's only one service worker. Yeah, so there's one service worker for all documents that match the pattern that you register with. So let's say I've got 3 tabs open that all have acme.com/app open, right? They'll all be talking to the same service worker. And that same service worker might even go away, right? It might get killed, but their requests will all go to the same one. That's a optimization that we need to make in terms of memory and also for sanity. Because if you have multiple service workers running at the same time, who owns your databases? Like, who owns the model? Who owns the caches? That's not, being coherent about those things isn't a game that we want to really make any harder than it has to be. I don't know if that's a good enough answer, but yeah, you'll see one service worker ever for a particular match. Yeah. Yeah, so service workers do live in front of the browser cache. So what happens here is if a request comes to the service worker and it doesn't satisfy it, it will go to the browser cache and then to the network. So it is the case that you can think of service worker as being like a managed cache in front of the browser cache. But if there is an entry in the browser cache that would satisfy the request, you'll get it from there before going to the network. So we don't give you visibility into the cache to avoid things like fingerprinting risk. But we do play well with the cache. And in fact, in the Chromium implementation, we're hoping to share resources in the underlying storage area so that we're not like let's say one of our big issues is that lots of sites request fonts, which can be very large, especially for CJK languages, multiple times. And so you can have 5 to 8 megabytes of fonts for a main body text font in Chinese. It'd be great if you weren't having to re-request that all the time. So the thought is that we'll deduplicate those and make sure that we can use them as look-aside storage without having to make you change the way you write your application.
DevTools.
DevTools. Oh, great question. So let's see. So one of the things I did last year was that I added the console, in preparation for this, is that I added the console APIs to workers in general. So now worker scripts of all kinds, shared workers, non-shared workers, all have that. If you go to in a dev channel build of Chrome, chrome's://service worker-internals, you'll see all the currently registered service workers, and you'll have the ability to inspect them. So now, let's see, window. Window is not a thing, right? We're in the service worker, but self is a thing because it's a worker, right? So this is a service worker global scope. Yeah, so DevTools is coming. DevTools is on the way, yes.
In the current caching field, will you be able to listen for a response request for image URL or something like that? Get the URL, get the image, manipulate it, and give back the browser's response?
Yes, will you be able to? For same origin and CORS content, yes. So one of the invariants that we have to maintain is that if it's not something that you're meant to see, the service worker can't enable you to see it. So cross-origin content that doesn't come with a CORS header will be opaque. There is a response type called opaque response. So if it's your image and you have permission to read the bytes, then yes, they will be available to you. You can do whatever you want. You can use Canvas inside of workers if that's available in your implementation, and you can hand back your own thing. Absolutely.
And range requests for like video?
Range requests for video? Probably. That's a tough question. There's a lot of stuff about streaming media that we don't have yet. Like WebSockets are going to skip service workers for now, for instance. Yeah. No, sorry, yes.
Question regarding going over your allowed size. Is there any help to get the oldest out and that kind of thing?
Yeah, so one of the things that I'm in sort of constant communication with the editor of the Quota API specification about is that we're missing about 3 small things. The first is to know how much quota you're being charged. We don't have an API in the web platform today to tell you how much quota you're using, which is, so I think Kinyuko did add that to a recent draft of the spec. The next API is that we have no way for you to estimate how much storage you've got. I mean, there is an API for it, but it's not great. So you can know sort of how much you've got, and you can request more quota, but it's not easy. So you need to know how much you're using, and you need to know how much you've got, and you need to be able to request more. So two of those 3 are more or less there. But the last one is, let's say you're under storage pressure, right? This happens a lot. Like, I filled up my phone, and I want to remove the stuff that's not essential. It would be great if I got an event that said, hey, if you don't remove something, I'm going to evict you. And so we're talking about adding that event into the service worker thing. That's what I mean by Quota API integration. And the hope will be that you'll be told how much they would like back. Because it's not the case that all of your caches are potentially going to be meaningful. But it's also not the case that if you remove just part of them, or if the system tried to remove one cache, that it would make sense, right? Like, one of your caches might deal with the shell content, and one of them might deal with some data that's just like image caches or whatever, that's temporary transient stuff, and some of it might be your hard work, right? You sent it to the server, but you weren't able to synchronize it yet. Which of these should you evict? Well, that's an application level question. So our goal is to enable applications to make a reasonable choice about that, and not to sort of, there was discussion about priorities and all that stuff, and we'd have to retrofit every storage API in the system today, because like a lot of your storage quota might be used not by caches, but by IndexedDB or by local storage. So we want to give people a fair shot at doing the right thing by their users. File system API. If there's an asynchronous version of the file system API, we'll probably add it to the worker global scope. Yeah. Yeah. Can you share a service worker between different URLs in your domain? The service worker is shared between all URLs that match the scope. So if I say example.com/app/star, and I go to example.com/app message 1 and then message 2, they'll both be talking to the same service worker instance. And there will only ever be one instance that they both talk to. Yeah? Mm-hmm. IndexedDB is not in the sort of the browser cache. IndexedDB is a separate API that has separate storage. Oh yeah, yes, but again, that won't be necessarily shared. I guess we're running out of time. So thank you so much for all of your time, and if you got questions, I'll be around. Thanks.